Hi, ladies and gentlemen. Welcome to our little presentation where we will explore the latest updates in ABAP CDS. I'm Santiago Zuniga, and I'm here with
Boyan Boychev, also welcome from my side. And today we're going to show you how we do CDS development in pair programming.
All right, so let's get to it. In case you haven't seen last year's video, I'll put cure for your convenience here, so you may have the opportunity to see it whenever you want. So we had a data model from last year, and we've been tasked to upgrade it in some sense, right?
Yes.
It looks a little bit like this. We have some beer orders, with tables. We expose that data, and then we're trying to kind of analyze it. And then right on the middle, on the right side, we see that there are some like tents with the Oktoberfest theme and seats. And then we had some seat reservations and an analysis on top, but I'm not really familiar with the data model from last year. Do you have any idea?
I only saw the diagram. I haven't seen it in the system. Maybe we should go in the system and see what the source code says.
Right. Well, luckily, we have a new tool that we can use to actually, find a little more about it. Right. So we have all of these entities, but I'm not really familiar with what's inside. Now we can,
let's see,
simply, I think it was something like this. We just right click right here, and then
we go to the bottom.
We go to the bottom where it says Joule, and then it's explain. So let's try to explain this thing.
Oh, so we see the window on the right side. It just opened. And we've got an explanation. Cool.
All right.
And what does it say? So it's got two parts basically: the purpose and questions that can be answered with the CDS view. Cool.
Right. So let's read a little. So it serves as an interface for managing beer orders during the Oktoberfest event. I think it's quite accurate. It captures essential details such as the quantity of the beer order, the unit of measurement, total amount, and the currency that's used. We also record the order date and associates each order with specific beer brands, seats, and tents through defined associations. Wow, okay, I think I'm getting a panorama of this thing. And it looks like the second part says we can, this CDS view provides some data that answers possibly answers some of the following questions. What is the total quantity of beer ordered for a specific brand?
Yeah, but we should also consider, I think that's an explanation using AI, so it can have some hallucinations. You should also look at the source code, but this looks like a good semantic description for the entity.
Right. This helps tremendously for at least getting an idea of what the information that is inside this view entity actually contains, and maybe we can actually answer some of these questions even if we need some additional work, so to speak. Yes. Right? Great. So let's go back to the presentation. So we have done the beer orders, but we've been given some tasks by our boss, like it is. So our first task will be to develop a prototype Fiori applications that enables the users to do the normal adding, deletions, and the updating existing beer orders.
Mm-hmm.
Afterwards, I think he wanted some analytics. They might come into play. So we'll get what was the percentage of beer sales amount per brand relative to the total beer sales, and analyze the sold beer quantity of various beer brands across different weeks for comparison. And lastly, compare the sales of beer brands based on their geographical origin. So we have a lot on our table. It was quite an ambitious task list, but we can get right into it.
We've got a full backlog. Let's get into it.
Right. So before we actually write some code, we're concentrating ourselves on the left side of this diagram, so we're only doing, things on the beer order part of things. And in order to do that, we just take this classical beer order data model, and we're going to turn it into a RAP-based Fiori app. It will make our lives easier. Before, we needed to actually, have a table, and we needed to have a view entity, and then project that data, and project it again, and then we would have like a complete stack of view entities for the for the RAP framework. But now with table entities, we can simplify this development, and as you can see on the right side, we only need a table entity to act as a business object.
Oh, and we can do the projection view right on top of the table entity?
That would be correct. Cool. So it means with this projection, we only need to define a few behavior definitions, and then the service definition and service binding remain minimal, and we can already deploy our things. So, right, let's get into the code. Right, so in the code, you see we have the beer orders. For time's sake, we have already replaced the table and the view entity we had with this table entity. As you can see, the root keyword defines that it's a business object, and we have some basic fields such as the beer brand name, right? Marked with beer brand, our quantity, units, amounts and currencies, as well as order date and time, and we have a field that is seat, which is just the identification key for the seat.
But otherwise, we didn't need to change anything, right?
Otherwise, we didn't change anything. It's exactly the same. Same fields.
Great.
And but we now have the business object itself. So to actually create a behavior definition for this, let's just right-click this and create a new behavior definition for this. It's going to be a managed behavior definition, so we can just click next. And it looks like we might have already one of those. I think we can look for that quickly.
Oh, so someone just
did it for us.
That's also great. So there's the behavior definition, and there's also the behavior definition for the view on top.
That would be correct, but let's take a quick look at it if you don't mind. So our task was to have users to be able to edit and add new data right on the Fiori app, and we could do this with the draft keyword. And with this draft keyword, we're selecting our old table as a draft table. Unfortunately, table entities are not supported for draft tables at this moment.
But right now, right?
But right now,
it should be supported in the future.
It should be supported in the future. And well, we can see the normal operations that we wanted. So create with the we have a create action, an update action, a delete action, and we have the UUID. But we also enable the draft actions that are needed for the users to actually do these actions, right? So we have the draft action edit, activate, discard, resume, and prepare. Right, with that done, the next part of our RAP business model, we needed to project those values. We already have that right here. So as you can see, right now we have the root view entity, the defc beer order, and we can define that as a projection of our table entity. It has the provider contract transactional query, and as you can see, it's a very minimal view entity where we just get the base fields We're even propagating all of the annotations, so we don't have to include them here. And like the last view entity, we're gonna create our behavior definition, also with draft. But now it's very simple. We just kind of propagate what we define on the table entity, on the behavior definition of the table entity. So we have, again, all of our CRUD operations, and what we would need to do in this instance is only expose that to a service definition and the respective service binding, and we will have already a wrap Fiori app.
Cool. So this is just a projection, so to say.
This is just a projection of the data.
We didn't need to do anything else.
We didn't do anything else. We didn't do anything else. So let's get right into it. We have the beer order projection. We click new service definition, and now we need to define a new service. So we just have this service definition, and we can give it a meaningful description, and we click next.
Oh, somebody already did it for us.
Somebody already did it for us again.
I think it's on the top.
It's on the top.
Next to
you're correct. You're totally correct. We have a service definition, and in this instance, you see, it's just 3 lines of code. It's the beer order, and we expose our projection, and that's it. And the service binding that is that references the service definition, as you can see, is using the OData 4, OData version 4 UI, and we just can click directly in preview, and we should be able to actually see our Fiori application. Sorry, I forgot to actually click looks like it opened this side. Sorry for that. Oh, well, look at this. We already have what looks like a Fiori application, and I think if we click go, we can see already a nice amount of beer orders. Great.
Quite a lot. We also see the order time. We've got the option to create new ones. We've got the option to delete. That's great.
Right. I think we've already created the task list. But look, we can create it. We can add our own beer orders. I think that's great. So let's get on to the next task.
Let's see, what's the next task? Then?
What's our next task? So our next task would be, what was the percentage of beer sales amount per brand relative to total beer sales? What do we need to do in this case?
I think those are all tasks that have something to do with analytics. So maybe we can just create an analytical model, right? So we've already got the wrap model, we've got the table entities, and we can directly just modify it a little bit and do a analytical model on the side.
Right.
So and use embedded analytics, right?
So the base objects are already all there. We just need to enhance them with the analytics section, and then we can analyze the things that we want with the new engine, right? And
we've already tried to do a diagram on what we actually want to do in this example. So we've got, let's see, on the left side, we've got our classical beer order analysis that's already in the system. And now on the right side, we've got the star schema. So basically the new analytical data model that's parallel to the wrap model. And as we see, we here have the beer seeds, the beer brands, they're basically the same. Those are just dimensions. Then we've got the beer order table entity. It would be our root, so to say. And then in the middle, we've got the beer order view entity, the interface view that we just saw, that combines everything and associates the seeds and the brand. And also, then we will need to, so to say, create the heart of the star schema. Analytical star schema. It's the cube. It's right in the middle, and it's got associations to O of the dimensions, and it's also got the measures, and you can do then quite simply analytical reporting on top of it. So now for the 3 tasks, I would say we can see maybe we just create 3 different analytical queries, or we enhance.
For each use case, pretty much, right?
Exactly, or of course you can also enhance some of them. So as we see, we've got 3 different analytical queries right now: the beer order weekly for the weekly comparisons, the beer brand global to see so which beer from which region sells the best, and so to say. And again, we want to do a comparison between the previous week and the next week to see if it's all going well, and that regarding to the quantity, so how much liter beer was sold. It's a Devtoberfest. It's
yeah.
That's what's important today.
Yes.
So let's open the model and see. So now we've got the beer order right here. So this is our interface view, and we would start there. But first of all, I would like to, so to say, convert the table entities that we've already got to dimensions. Because as we said, table entities, they can now be also used in embedded analytics, and we can directly add the annotation analytics data category and then dimension. We can try doing it, and this signals to the ABAP engine, to the analytical engine for the runtime, that it's actually a dimension in our case. And let's see.
Oh, we're getting an error.
We're getting an error.
What could that be?
That's funny. So there's a field beer brand description. And it says that the type string with length 000 is not supported. I know, right? I mean, we only so the ABAP engine at runtime only supports characters to 256. So that's the error that we're getting.
The length of the character chain is only
exactly. So we can actually change that, right? I mean, our descriptions are not more than 100.
Yeah, we don't need 1,000 characters.
Exactly.
For that. I think 250 would suffice.
They're already in the system. Let's try. We'll do a character with length 250, for example. Oh, and now we get an error. Of course. I mean, this now was we want to actually do a conversion. On the database, we've got a string. Now we want a character. So that's
Do you think I need to go to the SE14 to actually change this?
No, because I saw that right now we've got quick fixes in ADT for that directly. Mm-hmm. So if we open this and we make it a little bit bigger, then we can see that the quick fix actually says adjust and activate table entity.
Oh, and convert the data all in one. All right.
We can update it directly in the system. That's good. We don't need to use the transactions at all. Let's try it. Double click it. Oh, and now we see it's applying the quick fix directly. And if everything works fine and we haven't got any descriptions that are bigger, then it looks
like it worked.
Exactly. On the bottom now we see it's executed. It's got a green mark. All should be good. And if we want, we can also look at the action log, the database adjustment log. But for our use case, I think always fine. It's already active. We don't get any error. So I guess it worked fine. So we would do the same, basically. So we would also want the beer tenth to be a valid dimension. So for that, again, we do basically this. And we can also copy this header annotation, and we would also want it for the seeds, just in case that we want tens or seeds in our reporting. I mean,
you never know in the future what you might
know.
want to.
It's best to have
analyze.
it right there.
Yeah.
And just do it afterwards. Exactly. So that's already done. Then let's go to our interface view. So the interface view, our peer order, it was already there, and then we can use it to create a cube on top, an analytical cube. And the analytical cube, it's just the heart and soul of the star schema. Everything is basically there that you would need. So let's create one. So we go to new data definition. We give it a good name. For example, in this case, it's again an interface view. This one's quite good. And then we can give it a description. So let's see, Devtoberfest, and I would like it to be a peer order cube. And I don't think that we should do anything more, right?
No, I think that's.
We can go to the templates. We can go to the templates, and then we would use define view entity for that.
You just need a normal one for this.
Exactly. So let's see. In our use case, we actually do not mind to propagate the annotations. So that's all good. We'll actually delete this header annotation, but everything else seems fine, I would say. I mean, the authorization checks, they're not required. We don't have TCOs for this right now. It all looks fine. The thing that is missing right now, actually a few things, but let's start with the obvious one. We need to say that it's a cube.
Right, so we set the data category to the or cube.
Exactly, it's a cube. It's our cube. And then let's see. So we've got basically all the fields. We can leave it like this, and we can actually also add our dimensions.
Okay.
Let's do it. So the dimensions that we would like to add is the seed. I mean, that's already there. Tent, it's already there. For the brand. For the brand, I would actually want to redefine the association so that it has its own condition. And we can do that. I mean, we can redefine associations on this level, or we can just use the ones that are coming beneath from the underlying level. For beer brands, I would really like to redefine it. So it would be an association of many to many, basically, to the beer brand table entity. Yes. Quite good. And then I would name it the same brand, so that it's overwritten, so to say. And then let's see, on dollar projection, and I would like the beer brand to be compared with the beer brand from the corresponding dimension. So brand beer brand. And that's all good. Now we want to also add a connection between this beer brand and the corresponding dimension. And for that, we would actually need to add the following field annotations. Now, for time purposes, I'm just going to add them directly and not type them out. So, what do we see? Oh, that was the wrong one. Sorry for that. We would need a object model foreign key association to brand. Basically our dimension. And now for the others, I mean for the seeds it would also be good to add a foreign key association to the seeds. We can do that directly. It's
directly
actually
at the seed ID level, right?
Exactly. It's the same. It doesn't do anything else.
Yeah, we would always like to keep our data model clean with these foreign key associations.
And the same we do also for the tents. So, quite good. And right now, there's a few things that are actually missing. So, the things that are missing right now is, if we follow the guidelines, at the beginning, we should have our dimensions. So the things that we want to aggregate on, and so on. And at the end of our cube, there should be the measures, the things that we're actually aggregating. So let us maybe do something like this. So these are our dimensions, the order date, the pure brand, the seed ID, the tent ID. And then afterwards, we paste in our measures. So basically the quantity and the amount. Mm-hmm. And for these two fields, quantity and amount, we would actually need to define an aggregation strategy. So do we want to summarize it? Do we want the average? Do we want the max, the min? There's many options. And we do that using the field annotation, aggregation, default, and then we just use, for example, for quantity, sum. And I would say it makes a lot of sense to actually summarize it also for the amount, right?
Yeah.
In our tasks, it just makes a lot of sense. And now, if we go on, we can actually activate this cube. It's already there in the system, and it should be working quite fine. So, now, we would like to do the first calculation. And what was it exactly? I think it was the percentage, right?
You're correct.
We want to see the beer brands that were sold and how much, so that you can compare it. Which beer brand sold the best, and so on. So let us then define a analytical query on top of this cube. It's just what we do. On top of cubes, there come analytical queries, where you actually do the whole reporting on its own. So it's a C view. Let's say that we do the beer order weekly comparison, so that we see that what it does, basically, depending on maybe the weeks and maybe the days and so on. And let's see, Devtoberfest, and then beer brand order comparison. And here we can actually use the template for defining analytical projection views. It's also quite good.
It's quite handy to have.
Yeah, it basically spares us a lot of time. So here the label is a little bit too lengthy, but we can leave Devtoberfest.
I don't think we need the key.
The key we can't have key for this.
Right.
And we actually in the analytical reporting, we only need the fields that actually matter for the reporting, right?
Right, so let's just get rid of all of them and add the ones that are really important to us.
Exactly. This would be, in our case, for example, the beer brand, I would say. Because we need to do a comparison. And afterwards, we want the amount.
Right.
But I would say we sell in different currencies. We sell in euros, we sell in dollars. I mean, wouldn't it be better if we actually do that only in euros, so that we actually see the...
Right, we cannot really compare all of these different currencies because there's exchange rates between them. It would only confuse us.
Exactly. Mm-hmm. So let's do a currency conversion, I would say.
I agree.
So I would actually do a currency conversion for that. So we also need the target currency, and for that let's say just euros, right?
Yeah, let's just use euros as for example.
Okay, that's the euros. And then we also need the exchange rate date. So I would say that's actually the order date, right?
That would be correct.
It's the same date.
Yes.
And let's name it, for example, sales amount. So, very good. And we see now we're actually missing the currency key. There's nowhere to be found. So let's go on and add it. Mm-hmm. So this is a calculation. Mm-hmm. I would say we would do. I mean, right now we know that everything should be in euros, but it's a good practice to always have virtual fields in analytics when you do some calculations, because virtual fields, their value is actually determined at runtime.
Right, we don't need to have them in the database.
Exactly.
We can just use them for the analytics, for the query.
Exactly.
And the moment the query is needed, then we'll calculate it.
Exactly, and you sometimes you just don't know which currency is going to be used, right?
Correct.
I mean, it could be that you assume that it's one and it's totally different. So
we could also tomorrow change this query and use a completely different amount.
Exactly.
Or change the exchange rate date or whatever.
Exactly. That's always the case. So now we've got semantics, amount, currency code. That's the annotations that we want to use to assign it. In currency in euros. And that's all good. And then we've got to actually annotate it also with, I mean, it's basically a calculation and it's then a formula. So
correct.
From the point of view of the OLAP engine, it should be a formula. I mean, it would work also without this annotation, but it's so to say a good reminder. So we use formula, and then O is good and fine. And now let's also maybe compare the percentage. I mean, we can also do some things. We would like to see the percentage sign. Let's define it as a ABAP unit, and we would call it a percentage unit. And then let's use a scalar functions, right? I mean, we have scalar functions that can do some things for us. Right. In analytics, we've got a lot of them. For example, we can use ratio of. That's a scalar function, and there we need to give it the portion and the total, right? I mean, we can also see it here in its description. We can see that the scalar function ratio of provides a ratio of the operand portion in context of the total, and we see the handling here in the documentation. Oh, good. And the return is a text float 34, so looks fine. And as a portion, I would say we give it $projection, sales amount, and as a total, we can use another scalar function for that. I mean, we don't have, in the metadata, we don't have the total, right?
Right, we just have the singular amounts for each clear order. Now we need to get the total amount.
Exactly, we need to summarize it. So with embedded analytics, you can do that, for example, using the scalar function row total. There's two ones, row total and grand total. Depending on your use case, you use the one or the other. So row total means that you get the total for the corresponding row. I think that's quite good for our use case right now. Mm-hmm. So let's use it, and we need to give it the corresponding measure. And it's basically the same. It's dollar projection, and then we add the sales amount, right? And then we want to see it as a percentage. So right now we will get 0 point something something. Mm-hmm. For simplicity, we would multiply it by 100. And then we would assign it the semantics unit so that we see the corresponding percentage points. Mm-hmm. Exactly. And now we can change this. We can add semantics, then quantity, and then unit of measure. And then we just add our percentage point to it. So it looks good. Then we get the aggregation default formula. Again, because, I mean, it's a calculation, you just add it.
We need to add it every time we're calculating something.
Exactly, it's like a pointer that you actually want to calculate it, that you actually want to calculate something. And for the UI, we would actually also like to have a end user text label so that it looks better and we know exactly what it is. And I would say this is just part of total sales. And let's do this also for the others. So the sales amount.
Just to be that bit clear on what it's going to be shown on the UI.
Exactly, so that it's easier to understand. We can just add just sales amount, I would say.
I think you're missing one little apostrophe there. Exactly,
this one, right?
Mark.
Exactly. Those mistakes happen. And now for the beer brands, we want to show it. We want it to be in a row. I would say we just use the analytical annotation, something like that goes in this direction. So analytics details, query, and we want to show it in the rows. We want to show the totals. So let's see how it goes.
So let's just activate it.
We activate it.
And in a matter of a few seconds, look, we already have it activated.
Perfect. Let's see. What does it do right now?
Can we get a data preview of that? Oh, look, and then we get our own multi-dimensional analysis app for this purpose.
Ooh, quite good. So
wow, let's take a look.
As we see, we've got our different beer brands and the sales amounts of it. So it looks like pretty much they were not the same, but people actually do not prefer one or the other.
Right, it's if you think about it, it's like really the spirit of the Oktoberfest, right? Everyone tries to take all kinds of beer and try them, right?
Yes.
That's what we're seeing right here.
Yes. And we can go actually a step further, and then we can go and actually change and we can do the other tasks maybe. So what was another one? It was the quantity comparison, right? With the previous week.
That would be correct. We wanted the sales amount
exactly
and the quantities. Mm-hmm. We actually want to see how much people consume alcohol.
Exactly,
right?
but for that we would but the problem is we right now have only the date. We don't know any information which date corresponds to which week.
You're correct.
We need to add this information in the cube so that it can be used.
And how do we do that?
For this, I think that we can just use, for example, the iCalendar date.
Oh, we can use that.
It's an entity. It's already there, and it can tell us basically which date corresponds to which week, or to which year, or to which quarter, and so on. So for simplicity, I'm just going to right now copy paste it, and we see an association to iCalendar date. We see the alias, and we see the corresponding on condition. It's calendar date to dollar projection order date. And now, let's say it's also a dimension. So we add it to the first part of the cube. And we would only need this for the weeks. So I would expose order date, and then year, week. And I would give it an alias actually, order, week. So that's all good, but for it to be recognized, we would actually need a little bit more of a semantic information. So we add this. Two field annotations. They're just saying that it's actually a year week. Its value is derived from order date, and then we've got our description.
And our description, we can just short it to week, I think it's
good. It was fly week in my example. We can short it to week or order week, right?
Order week would be the best option there. Yes.
So we quickly activate it. And then we can maybe just create a new query for this example, right?
Mm-hmm.
Let's see. We create one. It goes something after something like C, I would say, peer quantity week difference. Oh, here's a good suggestion for that. And I would say DevTurber fast week comparison or weekly comparison.
I think that's weekly comparison. Yeah.
Exactly. And again, it's a projection view.
With an analytical projection.
Exactly. And now, because of the time constraint, I'm going to directly add the source to it. So let's see it.
So, again,
what do we do?
We took everything out that we didn't need, and we just exposed the things that we actually would like to know, right?
Exactly. And what do we do exactly here? We've got our analytical query.
Mm-hmm.
It's a projection in the cube, and then we've got an association, the source code, current member use case. So we self-associate. But in this example, the association, we compare the previous, so the order week that we have in our cube with a calendar shift. So this is another scalar function, analytical scalar function, that does a calendar shift. So as we see, we give it the base. The base is the order week. We say that the base level is the week, so the level that we want to shift on is also the week level, and we want to shift by -1 to compare it to the previous one.
Mm-hmm. So -1 week.
Exactly.
And then we just get it.
Exactly. And then in our example here, we actually don't want to see the unit. The unit is always in liter. We just need it there. The brand, it's already there. The order week is the important thing, right?
Mm-hmm.
Then we've got the quantity. It's already there. And then we've got the previous quantity, so the previous week quantity. And again, here we see a calculation, right? It's basically, then for that, we do a virtual field. That's, as I said, the best practice. We also have this field annotation, semantics default formula, and we give here the connection between the unit, the virtual unit, and now the quantity that we see here. And what we do here, we do simple division. It's quantity minus previous week quantity. And let's see if all goes good. We should see a comparison between the amount that was sold current week of the day of the order date and the previous week. And if we look into our data preview here, we can actually see it. So in week 38, we do not have a previous week. So the difference is the same.
That's where it started, right?
It's the same. But we see now in the second week, a lot more was sold. I mean, week 38, it only had 1 day of Oktoberfest. So that's all good. And we see there's a lot more beer sold. And then we see actually it was quite good. On the 40th week, it was also quite good. It sold a lot more. So we see the difference. And then for the 41st, that was the last week basically, we see that it was a lot less. But I mean, at the end, it's a lot less. It's always like that.
Yes.
And then for the previous week, then there was no Oktoberfest. We see just a minus. That's all good. You can actually tweak that with, for example, case expressions and so on. But right now we see this example.
We built a prototype. That was our task.
Exactly. And now for the last task, we actually wanted to have also to see what was the origin of the beers.
Right, an origin analysis for the beer brands,
Exactly.
right? We have now the quantities, everything, very general, very, total amounts and so on. Now we actually want to know, okay, is there any difference between the popularity of each beer brand depending from where it comes from? Is there something like that?
Exactly.
Let's find out.
Exactly. That is all that we want, and we can do it because we have already had our colleagues build a hierarchy on the dimension level of the beer brands. So that is already there. And now we can do a origin comparison, basically. Again, nothing new. We just want to have an analytical projection view. And again, for the sake of time, we're going to just copy paste the source right here. And let's see, it's no different. It's not a lot different than the other one, but there are some differences. For example, here at the beginning, we've got our brand association, so our dimension, and we want to use a hierarchy from it. So in this hierarchy, we actually want to see the origin. And we know this is the node, for the hierarchy ID, node is geographical basically. There could be others, so we want to specify it here.
Right, it's not limited to geographical ones. You can create all manner of hierarchies, like an ABC hierarchy where you see everything in in a different order, or maybe you have a specific use case. Well, you can also build such hierarchies.
Exactly. These two then, the beer brand and the association to the brand, it's just something that is there for technical reasons. It needs to be there, so we hide it actually. And then we see nothing more than the thing before, right? We see the order week, sort of order comparison. We see the beer brand, and here for the beer brand, we see actually something different. We see display hierarchy was used here, so we can see the hierarchy, and then we actually need to specify which hierarchy and it would be used. That's all good, I would say. And then we would actually use text arrangement for the text only, so that we see the whole different. Is it Europe? Is it maybe, I don't know, Asia and Japan and so on, the countries? We want to see the text only. And then we have again our currency conversion. This was already done beforehand, so I will not explain it again.
We just activate it, and let us go to the preview as soon as we can. Yeah.
And then in the preview, we would like to see the origin. So depending on maybe where the beer comes from. And we can see here for the different weeks. For example, for the first week, we have so much beer sold, and we see the most beer which was sold was coming from Europe. 22% was coming from the Americas, and from Asia only 8%. If we want to go a step further, then we can see that the most beer, it was actually sold from Germany. So Devtoberfest, German beer, it's nice. And then if we open it, we see that the two brands with origin Germany, those are Alpenbräu Gold and the other one. So
a little disclaimer, obviously these are all generated randomly. Any similarities to the real world is pure coincidence.
Yes, but they're quite good, I guess.
They're quite good, yeah.
Exactly.
I would like to try it.
So I guess we actually fulfilled the whole backlog.
No, you're right.
And then our task is actually done. So we have the analytical model, we have the tree queries that actually do everything that was needed. And then I guess that is all from our side.
And all good things must come to an end, right?
Exactly. So thank you very much.
Thank you very much for your attention, and I guess we'll see you in the next one.